Hey guys, so in this video we're going to be differentiating by first principles. So that means we're going to get a function and we're going to differentiate by using this the first principles, which is like the most fundamental way of differentiating and the most sort of logical, but often can be quite hard to grasp, as well as it's a lot more time consuming compared to later on. So you typically only do it when the question does say differentiate by first principles, but it's good to get an actual understanding of it first, as it means that differentiation will make a lot more sense to you with regards to concepts later on. So to begin, we'll look at this graph here. So we have fx is equal to x minus 1 squared. So what is the differentiation? Well, it's trying to find the gradient. So what we want here is we're looking at the gradient. So always keep that in mind. So we want to looking at the gradient. So I'm going to take 2 points. So I'll take this point here. I'll take this point up there. So that's P and that is Q. So this is at a value, let's say X. So this is Y and that's X. And it's governed by this equation. So we have here X. And at the moment, I'll just do it with regards to general. So we have fx, and we have x. So that point there is x, fx. What about this point here? Well, we'll say this comes down here. We'll call this distance h. So that's h. So that means that point there is going to be x plus h. So this point is going to be x plus h, then fx plus h. So it's going to be f, but then you have to sub in x plus h to all the values of x. Now, if we find the gradient between these 2 points, not on this, just a straight line gradient, so we'll look at this line here, then we can work out this gradient as being rise over run. So m is equal to rise over run. So that means we can say that m is equal to the rise, which is fx plus h minus fx, over the run, which is x plus h minus x. So the x's cancel and we get this is equal to f x plus h minus fx over h. So if we want to look at the point P and we want to find the gradient of this line. Now I have this line and we can say that the gradient here is probably equal to this purple line there. And this green line obviously isn't the same as the purple. It's fairly close, but it's not exact. But what happens now if we get closer? So what about if we brought Q closer? So what I'm doing here is I'm reducing h. So as I keep on reducing h, and keep on reducing h, and keep on reducing h, I'm getting closer and closer to the purple line. So as h gets smaller and smaller, I approach this. So that means when h cannot equal 0 because it wouldn't be defined, and if h isn't equal to 0, you've just got 1 point. However, if h approaches 0, this is what the gradient is going to be equal to at this point. So as h approaches 0, we can say that this gradient is going to approach this gradient here. So we can find this gradient at P by using this formula and then saying that h approaches 0. Because if you understand this formula, fx plus h minus fx over h. So this is made from rise over run between 2 random points. It doesn't matter where they are, as I've done them in general. So it's important that you understand how these 2 points are, the coordinates of these 2 points. And then I said what I'm doing is I'm reducing h. So I'm making h smaller and smaller and smaller. And what this does is it means it gets closer and closer to purple, the actual gradient. And when h approaches 0, so it's the smallest value it can be, approaches 0, then we can say that this is a gradient of the line. So all we can do here is we can say that we have, in general, we can say that if we want to find we want to differentiate with regards to the equation, so we can differentiate, we can say that f dash x, so differentiate is equal to the limit of h going to 0 of fx plus h minus fx over h. And because we're doing it in general, so we're leaving h as an actual value when we're calculating it, we're not as a specific value, we're not calculating a specific value of x, then that means we're going to get it in the general term. So if we had the previous example, which was x minus 1 squared, then we'd find that we'd differentiate that and we'd get 2x minus 1, so we'd get 2x minus 2. So I just calculated that using a different method rather than first principles. But I'm just saying I'll go through an example in a sec where I go through all the steps. But what you're going to end up with is an equation which you sub in the x value and it will tell you the gradient. So you can sort of think about like the gradient is equal to 2x minus 2. You sub in the x value and it will tell you the gradient. And this can interchangeable. So we'll look at an equation. So differentiating using the first principles. So we have the equation here. So the limit of h going to 0, fx plus h minus fx over h. And so remember this, try and think about what it means. We have x plus h minus fx. So this is a rise, and then the run is just h, so the distance in between the points. So if you remember that, rise over run, and then we have to think about the h getting small as possible, so h approaches 0. So what we do now is we have this equation, and we sub in the points. So when we're saying fx plus h, what this means is we have to sub in x plus h for every x value. So x plus h squared minus x plus h plus 2. So we'll sub in these values. So we get the limit of h going to 0. We'll leave that there for the moment because obviously if we sub it in now, we'll divide by 0, it's undefined. So we get x plus h squared minus x plus h plus 2 minus x squared plus 3x minus 2. So what I've done then is I've gone minus fx, and that's given me negative x squared, minus minus gives positive, and then minus plus gives a negative. So if you want to do that in 2 steps, you can do that if you think it will reduce the amount of errors you make. And then this is all divided by h. So this is continued. The limit of h going to 0 is equal to x squared plus 2xh plus h squared. So I've just expanded this out. Minus x minus h plus 2 minus x squared plus 3x minus 2. This is all divided by h. So it's quite easy to make an algebraic mistake here, but it's not too bad because once you know how to do it the other method, it's quite easy to double check if you've got the right answer or not. So x squared minus x squared. Then minus x, this should be, I've forgotten a 3. Yeah, minus 3. There should be a 3 there. So we're going to get minus 3x minus 3h. So that minus 3 cancels with the plus 3x. The minus 3h cancels, doesn't cancel. The plus 2 and the minus 2 cancel. We're left with 2xh plus h squared minus 3h. So if you want to double check your working at this stage, you don't want to have any terms without h in them. So if you have a term without h in them, then you've done something wrong. So you only want terms with h, and I'll show you why that's the case. So I'll just rub off the top now. So we have this. Then I can say the limit of h going to 0. So the top, I'm going to take h out. The reason why I can take h out is I said that no matter what happens, every term's going to have h. And if you've done there's not a h, then there's been an error somewhere. So I've taken h out. Now these can cancel when h does not equal 0. But we don't care about that because we're looking at the limit, and it doesn't matter if it cannot equal 0 at a certain point. So then we're left with limit of h going to 0, 2x plus h squared minus 3. So we can sub in h is equal to 0 here, it's continuous. Then we get 2x minus 3 as h is equal to 0 due to the limit. So we get 2x minus 3. So what we've done is we've calculated the derivative from here. And then another check, if you want, is that there shouldn't be any h's in the final answer. So it should only be x terms or constants. So we had the original equation. Fx is equal to x squared minus 3x plus 2. We've calculated the derivative is equal to 2x minus 3. And this is quite easy to check once you learn how to do differentiation quickly. However, if it says by first principles, you have to go through every step and show each of these steps. Now, a lot of people just memorize the formula of limit of h going to 0 and then the fx plus h minus fx over h. And that's really important. You do have to remember this formula. However, I find that if you can understand what I went through at the beginning, it's a lot better for your understanding as well as conceptual framework for any further maths as well as for differentiation.